Okay, so section 10.2. We're going to introduce the quadratic formula. Quadratic formula is a nice formula for solving any of your quadratic equation problems. So ax squared plus bx plus c equals 0. Anything you can put into that form, you can solve with this formula. So the question is, what is that formula? Well, before I give it to you, let me briefly go through how it's derived. It's derived basically using completing the square, process we discussed in section 10.1. Now, as our couple examples this morning showed, to complete the square, the coefficient in front of the first term has to be 1. So to make this a 1, we'll divide through everything by a. That puts a 1 out in front of my x squared term. I'll move the c over a term to the other side where it becomes negative. And then complete the square. So that process starts by taking half of this number. 1/2 times b over a gives b over 2a. And when you square that, you get b squared over 4a squared. That means the left-hand side is a perfect square. You add that term to both sides. You've got common denominators here now, so combine them, take the square root, move this to the side, and there's two solutions to your quadratic equation based on the quadratic formula. So let's discuss those and then do some examples of the quadratic formula. So the overall formula is negative b plus or minus the square root of b squared minus 4ac over 2a. I've heard a lot of students say that their high school instructor used to sing this to their favorite college fight song. I will spare you that. I will spare me that. I'm not going to sing this to you, but it is something you have to have memorized. There are a lot of songs out on the internet. People do in fact, the one that I see the most when I do a search for it is the Quad song by this high school. I forget where, but you have to have this memorized. We will be using it, and more often than not, I ask you simply to write it down on your exam. So make sure you know this one inside and out, but let's practice it. What it's going to require is that we determine what a, b, and c are. A, b, and c are going to be your coefficients of the polynomial that you're working with. So, I don't know, let's start out with an easy one. Problem number 14. X squared plus 3x plus 2 equals 0. So the first thing I have to determine is what a, b, and c are if I'm going to use the quadratic formula. Now a, b, and c are the coefficients of my polynomial. What are those coefficients in this particular case? 1, 3, and 2. Now what I suggest that you do, especially when you're getting used to the quadratic formula, is to fill it in, or fill in the parentheses. So let's fill in the quadratic formula with a bunch of parentheses. And the reason for that is because later examples, when we start working with negative numbers, it's very easy to make a mistake unless you're being careful to write things with parentheses. So let's fill that all in. I'm going to fill in a 1, excuse me, how about a 3? 3, negative of 3, plus or minus the square root of 3 squared, which is your b squared, minus 4a times c, 1 times 2, over 2 times 1. And now our job is to simplify this. So how's that going to simplify? It's going to be negative 3 plus or minus the square root of 9 minus 8 over 2, which is negative 3 plus or minus the square root of 1 over 2. What's the square root of 1? 1. A lot of times people just leave it as a square root of 1. You can simplify that. You should simplify that. Now let's keep in mind that there's really two cases here. There's the positive case, negative 3 plus 1 over 2, and the negative case, negative 3 minus 1 over 2. Let's see what we get in both of these. Negative 3 plus 1 is negative 2. Negative 2 divided by 2 is negative 1. How about for the other one? What do I get there? Minus 2. So there's our two solutions. Minus 1 and minus 2. So this first example is really just to kind of practice and start to understand the quadratic formula. And we're going to do a lot more practice. So let's try a couple more here. Before I do a few more, let me point out something about problem number 14. On a test, I'm not going to say solve this by the quadratic formula, or solve this by completing the square, or solve it by the square root property. I'm just going to say solve it. That's all I'm going to do. It's your responsibility to figure out what you want to do. Now, would you choose to solve this one with the quadratic formula on an exam? No. It's like squirrel hunting with a bazooka. All right? You should look at this and go, oh, well, that'll factor. X plus 2 times x plus 1 equals 0. And there's my two solutions. Factoring is your best friend in terms of solving the quadratic equations you'll see. But factoring doesn't always work. And if it doesn't factor, you need a backup. And that's where the quadratic formula could come into play. Let's try another one. Problem number 24. Two x squared plus 7x equals negative 1. Well, let's think here. First of all, this isn't in the right form to even use the quadratic formula. So what do I have to do first? Yeah. Add 1 to both sides so that I get 0 on one side. In order to use the quadratic formula, you have to have 0 on one side. So there we go. You should always check to see if it factors. Now these are kind of tough, and it's kind of up to you. It's like, well, do you really want to spend lots of time trying to factor this? It depends how good you are at factoring these things. You could spend a lot of time trying to factor this and find out, hey, it doesn't factor. And then you have to use a quadratic formula or something else. In this case, this doesn't factor, so A, B, and C. Yeah, please. That's solving it a different way. That'd be solving it by completing the square. So you could do it that way. I'm going to practice the quadratic formula right here, though. So we don't need to divide by 2 on this. So our coefficients are 2, 7, and 1. So negative of b plus or minus the square root of b squared minus 4 times a times c over 2 times a. And let's fill in a, b, and c. So negative of 7 plus or minus the square root of 7 squared minus 4 times 2, which is our a, times c, which is our 1, which is negative 7 plus or minus the square root of 49 minus 8. Oops, I guess I left out 2 times 1 there. Over 2 is negative 7 plus or minus the square root of 41 over 2. 2 times, 2 times 2. Thank you. So that'd be a 4 here and a 4 here. Now, square root of 41 doesn't simplify at all, so we're in good shape. That's it. That's as far as you can go with this one. Negative 7 plus or minus the square root of 41 over 2. Now realize that this does represent two different solutions. Negative 7 plus the square root of 41 over 4, and negative 7 minus the square root of 41 over 4. It is quite possible that I could ask you for a decimal approximation to some of these things. Most likely I'm not going to be doing that in every problem, maybe just one. But let's practice how to find this, because we will need to do that for ourselves in section 10.3 or 10.4 when we start graphing these things. There's a couple ways you can do that. Let's do it this way first. We're going to calculate the numerator. So I'll put parentheses, -7 plus the square root of 41. Now you need to close off the numerator and then divide it by 4. Are you able to get about -0.149? Let's get the other root. Now we're going to be clever about getting the other root, because we've already typed this in. To get the other root, what change do I need to make? Just got to change that sign there, right? So here's the clever trick. Hit the second button and then the enter key, and notice what happens on your calculator. It brings up your previous calculation. So we don't have to enter it all, right? We just got to go back and change this to a negative sign. So you get these two solutions. Now if you got a fancy graphing calculator that has the latest operating system, a different way you can do this one is to hit the alpha key, then the y equals key here. That brings up this menu, and it'll allow you to do a fraction, kind of like the way we write it rather than the way you have to input it into a computer or a calculator. So you got a numerator and denominator, -7 plus the square root of 41 divided by 4. So a little bit more foolproof because you don't have to mess with the parentheses as much. You're going to have to, so if your calculator automatically puts in the left parenthesis, then what you're going to have to do is put in the right parenthesis. So if it does, square root of 41, then you're going to have to put the right parenthesis. That tells it to finish with the radical, that we're only taking the square root of this. You'll need double parentheses. So you need two sets. Yeah. So whenever you're putting in parentheses, the number of left parentheses has to balance out with the number of right parentheses. So yeah. Chances are yours would look like this. -7 plus square root of 41. Now when you put in the square root, it automatically gives you that left parenthesis. So then you put a 41, right parenthesis finishes off the square root, another right parenthesis finishes off the numerator, and then divided by 4. Okay, so good question. Yeah, please. Say again? The denominator? Right. So is that your question? From 2 times 2? Are we back up here? 2 times 2 was 4. Okay. Let's try a few more. My goal is to give you a few more, and then we're going to break you up into groups and let you work on a few. So let me show you some of the other things that can happen when you're working with these types of equations. Let's jump up to problem number 34. X squared minus 4x plus 8 equals 0. Now I'll save you a little bit of trouble here. Or maybe you can convince yourself. Does this factor? No. There's no two numbers that multiply to 8 and add to -4. So you got to use a quadratic formula or something else. I suggest we use a quadratic formula. A, B, and C. Mark, what would A, B, and C equal in this case? 1, -4, and 8. Good. 1, -4, and 8. Notice that Mark correctly nailed it on B. It's -4. And this is a good example for another reason, in as much as that negative b can be kind of a problem. So we get, let's see, x equals the negative of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So here's where, like I said, you got to be extra careful. Out front, you've got the negative of negative 4. So you get a double negative. And then again, these parentheses help out because when you square negative 4, what do you get? Positive 16. If you didn't have that parenthesis in there, chances are when you square it, you might get negative 16. 4 times a times c over 2 times a. Let's simplify this thing. Out front, the double negatives cancel each other out. And then what? We get 4 plus or minus the square root of 16 minus 32 over 2. Can I simplify any further? Nice, thank you. Sometimes there's some wishful thinking that happens underneath the radical. And as people will put a positive 16. That negative doesn't disappear just because it's inconvenient. We still have it. So it's 4 plus or minus square root of negative 16. Yeah, so square root of 16 times the square root of negative 1. 4i over 2. That's an important step. Boy, if you miss that negative there, you're really going to lose a lot of partial credit. I mean, I'm sorry, but it's just important to get that. Now, there's one last step that we're going to do here. And before we do that, let me remind you of something. I'm putting parentheses there. Why am I putting parentheses there? Those terms are married. If you break up that marriage, what am I going to write on your test? Homewrecker. Exactly. Can't do it. Now, you don't want to break up the marriage, but we can send, I don't know, the kids off to college. We can factor out a 2 here. Actually, we can factor out a 4, but let me just factor out the 2. 2 plus or minus 2i. Now, if you factor it, I'm no longer canceling into a parenthesis. I'm canceling between two things that are multiplied, and I can do that. You end up with 2 plus or minus 2i. Now, technically the GCF would have been 4. I probably should have factored out the 4. And then when I canceled, I'd be left with a 2. But it worked out fine like we did. Expect a couple problems that have complex answers. Okay, that's a nice thing about the quadratic formula. You can't get complex answers so easily when you're trying to factor things. But you can get them with the quadratic formula. Can and will. All right, how are we looking on 34? Okay, so let's try some more things. See some other things that can happen. Let's try problem number 38. So in particular, problem number 38a, 1/8 x squared plus 1/2 x minus 3/4 equals 0. Ready, set, go. This one's all yours. All right, I'm kidding. All right. Let me give you a little bit of help on this. Or maybe we can try and help ourselves. Does it look like a lot of fun to put those numbers into the quadratic formula? No. Perfect. Well done. Let's get rid of the fractions. what we're going to do is we're going to multiply both sides by 8. And that's going to get rid of the fractions. 8 is your lowest common denominator. So I'll multiply this side by 8, and I'll multiply this side by 8. So I'll do the right-hand side for you, and you do the left-hand side for me. Fair enough? Ready, set, go. All right, I got the right-hand side done. Who's got the left-hand side? All right, so that 8 has to distribute itself to all three of these terms. So you have 8 times 1/8 x squared plus 8 times 1/2 x minus 8 times 3/4. There's cancellation in all of these. Kennedy, let me give that one a shot. What's this going to look like when I do the cancellation? All right, perfect. That cancels. So I get x squared plus let's see. I'll put this as 8 over 1. Want to keep track where the 8 is. 2 goes into 8 4 times, so it'd be a 4x. And we got to do likewise with the last one. Good, minus 6 for the last one. So again, some cancellation. 4 goes into 8 twice. 2 times 3 is 6. So minus 6 equals 0. I think it looks a lot friendlier of an equation, right? A lot nicer to put this into the quadratic formula as opposed to our first one. Quick check though. Does this factor? If that was a 5, it would, but it's a 4, so we don't quite have enough. It won't quite factor. So A, B, and C, 1, 4, and negative 6. Try putting that into the quadratic formula. See what you can get. I strongly encourage you to write the quadratic formula with a bunch of empty parentheses and then go back and fill it in. Especially like with problems with the previous example, when you have that negative b, I see so many mistakes because people don't square it out under the radical or they forget the double negative in front. But negative numbers create a little bit of a problem when you're trying to work with the quadratic formula. If you get the square root of 40, good on you. Square root of 40 can be simplified as the square root of 4 times the square root of 10. You need to do a little bit more on this one beyond just coming up with the square root of 40. Okay, so let me just make sure we still have sound on this. Yep, still have sound. Okay, so -4 plus or minus the square root of 16. Now minus times a minus gives me a plus. So you should end up with a plus 24 there. Add those together, I get -4 plus or minus the square root of 40 over 2. Now, I mean, that's not bad, but there's a lot more left to the problem. So please expect to continue on these kinds of things. So it's going to be -4 plus or minus the square root of 4 times the square root of 10 over 2. 2 square roots of 10 over 2. And please, don't cancel the 2 into this or the 2 into this. What you have to do instead is factor out the GCF from the numerator. So 2 times -2 plus or minus the square root of 10 over 2. So we got rid of the GCF. There's no common factor between these two things now. But because we factored it out like that, now I can cancel. And now you get -2 plus or minus the square root of 10. Yay. How are you doing on this one? How many people got that one right after I at least came by and helped out? All right. Let's take a look at one more here, and then I'm going to give you some group work. So problem number 46. Let me just kind of double check that one in the book. -16x squared minus 16x minus 3 equals 0. Boy, I'll tell you, from my own experience, I see those negatives creating problems for people quite often when they work with quadratic equations. So here's what we're going to do. Let's get rid of those negatives. I'm going to multiply both sides of the equation by -1. On the right-hand side, I get 0. What am I going to get on the left-hand side? Thank you, gentlemen. So basically, it makes all those terms positive. And it's just going to be a lot less error-prone when you try and plug that into the quadratic formula or however you want to solve this. So give that one a shot. See what you can come up with. Okay. Did it work out nice and even? Okay. Did you get a nice even answer? Somewhat even answer? Nice fraction? Somewhat? Alright. So here we go. 16 times 3 is 48. Two numbers that multiply to 48 are 12 and 4. So split up that middle term. Factor by grouping. You can factor out a 4x here. Factor out a 1 here. Oh. I'm sorry. Did you guys use the quadratic formula? Oops. My bad. Oh, well, let me just finish this anyways. Factor out the GCF here, which is a 4x plus 3. Now, you've got two things that multiply to 0. So this times this is 0. One of these things have to be 0. Set equal to 0 and solve. Yay. All right. I'm just messing with you a little bit. But it is kind of needling you a little bit to realize that a lot of times these things are going to factor. And if they factor, great. The question you're going to have to grapple with is, how much time do you want to spend factoring these things? I know when I took this class here at OCC myself, I was terrible, absolutely terrible at factoring these things. I hated them. So, I have empathy. Although, I will say that no one ever showed me this trick, the AC method. So, I got to get my refund. Anyways, most of you probably did it with the quadratic formula, and that's fine. That's what I wanted to practice. So, should look like this. Negative 16 plus or minus the square root of, I guess I didn't need to use the negative 16s there. Plus or minus the square root of 16 squared minus 4 times 16 times 3. So that's 12 times 16 is 192, the difference of which is 64. Square root of 64 is 8. Now that's special, but please don't leave it like this. Please go a little bit farther and write as negative 16 plus 8 over 32, which is negative 8 over 32, or better yet, negative 1/4. Or negative 24 over 32 becomes negative 3/4. So notice I get the same answers as I did by factoring this. And that's great. I should. But, as far as factoring is concerned, my suggestion to you is look at it for a little bit. If you see how it factors, great. Factor it and solve it. If you don't see how it factors after just a little bit, then use a quadratic formula. Worst thing can happen is that when you get down to this point and your square root is a nice perfect square, one of those numbers on the left-hand side board, you realize, oh, man, I bet this would have factored. All right? So if you get a nice square root, then yes, it would have factored. But you know what? You can spend a lot of time trying to factor this and find out it doesn't work. So, all right, I'm going to end the video here, but I'm going to give you some group work to do. So you don't have to copy this down. I'll just kind of put it in here for the video. But let me give you some homework. I had somebody note for me very pleasantly the other day that I didn't include the homework in the video. So let me not do that again. For homework, try 15 through 67, and that's section 10.2.